Okay, good. So yeah, this is session 2 ESP32 and Wokwi simulations. I'm pretty sure I didn't cover these topics till now. So yeah, okay, let's start. So I'll just give a brief introduction. So there is this company called Espresso Systems, and they are based from China, and they are known for some of their very good microcontrollers, and those are namely ESP8266 and ESP32. And one point is that everything that they manufacture, I'm pretty sure everything is open source. So usually there are even several cheap alternatives for each and everything they manufacture. And okay, I'll talk about their most famous product shortly. But yeah, they makes they make chips similar to which we discussed in session one. That would be at Mega 328 or at Mega 08. This is one such chip which is manufactured by. Oh, okay, my bad. Okay, is my camera visible? Can you look at this thing which I'm pointing to right now? Is the entire thing visible? Yeah, okay, sure. So here I have a bunch of microcontrollers. So during session one, we were discussing about this guy. This is called Arduino Uno R3. This specific variant is a local knockoff. Obviously, like the original thing costs around 900, I guess. You'll get this for 250 or 300. And this microcontroller sitting right here, that is at Mega 328. This is a predecessor or like a weaker version of that microcontroller at Mega 08. I tried showing this in the previous class, but like I didn't set up a camera last time, so I'm sorry about that. But yeah, so this was the thing which I was trying to show in the last class. Usually, this is how majority of the ICs look too. And today we'll be discussing about ESP32. It is okay. I'll explain what exactly ESP32 is and like other parts slowly. But yeah, that's it for now. Yeah. So basically, a big Chinese company which have open sourced their entire work, similar to Arduino. I guess Arduino is from Italy, but yeah. So now ESP32. ESP32 is like a series of microcontrollers. It's not like a singular one. Uh, is there a comparison? Yeah. Okay. So as you can see, this is a okay. This is DigiKey. Actually, they are a pretty famous website, but in their website itself, when I look out for ESP32 microcontroller, you can notice that there are several series. Now, to be honest, at this point of time, it's pretty useless to know about what each of the series is. But what I wanted to convey is that ESP32 is like a series of microcontrollers. Now, okay. ESP32 is a powerful and versatile system on chip SoC. Now, fancy way to call a microcontroller. And some important points, it has dual cores, at least the one which we usually use, ESP32S3. I hope the S3 is visible here. That is something which you might come across in Insti because as far as I know, like some comp teams and many clubs, especially electronics club, use this particular microcontroller on their development board. So yeah, and the most important point being that it has built-in Wi-Fi and Bluetooth capability. I'll explain the importance afterwards. And as you can see, they have a or ESP32 as a DAC. So I guess after you did your assignment one, it should have been pretty clear that Arduino doesn't have a built-in digital to analog converter. Rather, it solely depends on PWM. But ESP32 has two pins which can act like a DAC, digital to analog converter. So yeah. Now on in the image that you can see right now, the ESP32 itself, the microcontroller is this small chip which is sitting on this larger chip. I'll explain about the larger chip now. So this is something called ESP32 Vroom. Now, okay, this is something which is in between a microcontroller and what do you say, a microcontroller development board. So yeah, okay. See, you cannot make your projects directly with this, but this is something which is usually available in the market. If you go outside to uh, so yeah, okay, sure. You can buy this module, but usually the development boards which we will come across have that module sitting on it right there. And usually there are some development boards which are very specific to
What is the Vroom adding? I'm not getting.
Okay, see, Vroom is something which is in between a microcontroller itself and a microcontroller development board. It,
Like that black part on that is what is Vroom.
I didn't get you it.
Like the microcontroller is just the metal part.
Oh, no, 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 no. Okay, see, Vroom is a module which has a metal shield with ESP32 sitting inside. Actually, this is the inside of a Vroom. Inside Vroom, you
Okay.
have a UART programmer, you have a transistor, I guess. Oh, okay, this is a Hall effect sensor, if I am right. And this is your microcontroller. So Vroom is a very fancy module. It has the programmer inside it, the microcontroller inside it, and one sensor extra. Is that clear?
Okay, yeah. So like the metal shield is what you call the Vroom. Or can it have a metal
All
shield
four
without
things
being Vroom?
combined. Vroom is the entire module. Vroom has a big antenna. Okay, see, ideally your ESP32 microcontroller does have a Wi-Fi capability, but the thing is the antenna is too small. So this big Vroom module, it has a big antenna. It has your extra sensor and also your programmer. And the thing is, usually the development modules that you have, it has Vroom on it. So it's like a small thing which is in between a microcontroller and a development board. It's like too specific and it's also too stupid.
Got it.
Yeah, okay, sure. And usually all the development boards that are there on the market, they have this Vroom module on it. So the second most famous ESP32 module is like ESP cam. It has a camera, this Vroom module, and it is a bit smaller than your generic ESP32. So yeah, that is what Vroom is. Vroom, you have a microcontroller, a extra sensor, a very big antenna extension for your microcontroller, and a programmer. So anything else? ESP32 Vroom module is a compact metal shielded Wi-Fi and Bluetooth enabled module built on an Express dual core ESP32 state system on chip. It integrates the MCU, flash memory. Yeah, that's it. There's nothing special about Vroom itself. It's like a small PCB or like a very small development board which is never used. Unless you're making your own PCB, that is. Like, uh, how do I explain this? Okay, see, sometimes there are projects where you use ESP32. And the thing is, it's a bit dumb to like buy your ESP32 separately, your Hall effect sensor separately, antenna separately. What is the difference between Okay. I guess I mentioned this in uh, session one, but I'll just go through it again. See, your microcontroller is this extremely small chip. It's a bare metal chip, but your development board is a big ass PCB which has several pins, LEDs, and some other indicators, capacitors, safety uh, LEDs, sorry, safety resistors, and etc. sitting on a big module. So, yeah, okay. In class one, I was trying to say that this is how a microcontroller looks like. On the market, if you go and ask them for a microcontroller, this is what you'll get. It is a bare metal IC that you use a programmer to program. Yeah, okay. Uh, uh, just can everyone see the new thing that I added just now? Please put a thumbs up. If not, try to make my screen full screen because like on my camera there are like several modules. So yeah, see, I'll just explain you briefly a small difference. This is at Mega 328 microcontroller. Oh sorry, at Mega 08. The number doesn't matter. It's just that this is a microcontroller. And the thing is, when you want to load your code onto this, you'll use something which looks like this. This is a programmer. So this programmer, you'll put it into your laptop, you'll connect some wires to this microcontroller, and then you'll program it. But the thing is, this is a bit stupid. Like you won't always do this unless you're a PhD student who is manufacturing these and wants to test this out. So usually you use something called a development board. Now, both this Arduino Uno R3 and Arduino Nano, they have this guy in a separate form. They have this microcontroller sitting right here in a way smaller form factor. And as you can see, apart from the, what do you say, this microcontroller itself, it has like a DC jack, it has a UART or USB-A female jack, and then it has a bunch of uh, female jumper pins, and also a crystal oscillator and some. Okay, sure, it has two crystal oscillators. I don't know why, but yeah. A development board is a PCB which has the microcontroller itself sitting and a lot of peripherals that helps you to prototype quickly. Uh, does that make it clear? I think so, Roy, you asked it, right? It's fine, it's fine. You were going on about printing your own PCB. Okay, yes. So those people who completed your electronics workshop, please raise your hands. Rafi, how many people? Yeah, okay, 15. Yeah, okay, see, when you went to your electronics workshop, I'm pretty sure those people gave you this board and told you to like uh, make this weird thing. So yeah, basically when next time for us, yeah, all the best of slide pen it is. So yeah, basically this is a perf board. Yeah, this is called a prototype board. And usually when you make PCBs, they are supposed to look like this. But yeah, this is how it will look. You'll have a board, you'll put a bunch of components, and you will have your central IC here. And the thing is, your ESP32 is a bit big. So the thing is, when your central IC is an ESP32, you don't put this entire module here because how do I say this? All these pins are kind of occupying too much space. So in that case, what you do is you rather use the broom module itself, this guy sitting over here, and put it over here. And why do you not put the microcontroller itself? Mm, because I don't think so they sell those, bro. I guess you only get the broom. So that broom thing is detachable. Yes, with the soldering iron, yes. Right now I can't remove it because it's like soldered on spot. But yeah, ideally I can remove it with a heat gun, a bunch of desoldering paste, and soldering iron. Yeah, that's what I was also telling this now. Hold on 1 second. Yeah. So this is your ESP32 microcontroller. This is the Vroom module, and oh, okay, yeah, and this is your development board. Okay, see, for now, take light on the fact that there are three separate things. It's just that you have something which is too small to use, something in between which is easier to like shift between long-term projects, and one thing which you can make short-term projects with. Does that make it a bit clear? Okay, one guy put thumbs up. I just hope that you guys understood. Okay, thumbs up. Cool. Yeah. So this is somewhere in between. See, the thing is, usually, like last year also, people didn't teach all this. But the small issues that afterwards, when you start talking to people who make projects, or like when you go to a store, it becomes a bit of a pain that you don't know these basic stuff. Like I went to like to buy some electronics, and like I told I wanted something. I was thinking I was asking for something, but I was like technically asking something else. So the shopkeeper was a bit annoyed. And then when he asked my college, I told IIT Madras, and that guy laughed at me. So yeah, we don't want that to repeat with you people, or at least that is what I hope. So yeah, so that is when I started paying a bit more attention. To be specific, I was trying to get a microcontroller, but that guy thought I was trying to get a development board. Actually, the black IC which I was showing you, I was trying to buy that, but I was asking for a Arduino Uno. I was asking for a big blue PCB, but I wanted a small microcontroller. So yeah, that was a bit embarrassing, and like I just don't want that to repeat with any of you. But yeah, take light. You're not in electrical engineering. You won't be buying microcontrollers or programming them. Very painful. Oh, never mind. Half of you guys are in E, right? All the best, bro. In 1 year, it's going to come microcontroller theory. Yeah. Okay. Yeah, that's fine. Half of you are in E. Yeah. Okay. Light on that part. The teachers will take care of you. Okay. A small comparison between Arduino and ESP. Now, the thing is, both of these are at this point coming at a similar price. You have an Arduino Uno R3 for 250 and ESP32 Node MCU dev kit for 350. It is a big name, but it's a development board. So yeah. So what is the difference? First of all, you can see a clear difference between speed. You have one at 16 megahertz, one at 240. ESP32 outdoes Arduino by 10 times. So that is faster. That means that you can run a bit more complicated stuff. One of that things would be running ML models. So it just so happens that you can run extremely light ML models on your ESP32. That's actually a very good thing. So you can also include AIML into your mini projects at a cheap price. That is very good, and I'll come back to it later. And some other points, there are tags in ESP32, but not in Arduino. So boo for Arduino. And then SRAM, flash memory, fancy names, but basically your ESP32 has 100 times or 1,000 times more memory than your Arduino. And it has Bluetooth and Wi-Fi, the most important thing. Usually you have to buy additional modules for Bluetooth and Wi-Fi. I had some of those lying around, but uh, give me 1 minute. Search for it. If I find it, I find it. Oh, I did find it. Interesting. So, extra space. Okay, for now, I'll just remove the programmer. So this is a Bluetooth module, and usually when you try to make Bluetooth projects with your Arduino, you have to add this to your Arduino project. So see, like you want Bluetooth for your project, you have to first of all buy this development board, then add this module, and that's like a bit too messy. Rather, you can just buy this ESP32, which makes your life a lot easier. So yeah, so basically sitting on Arduino, it has no Bluetooth, no Wi-Fi. It's extremely slow, and the memory is bad, and it doesn't have DACs. Yeah, that's it. Yeah, so basically, Arduino is a car which doesn't even work, and you have a F1 car which is ESP32, I guess. Although when you bring, what do you say, a Raspberry Pi 5, the image changes, but yeah, let's leave that for the future. Okay, so the end of the day, whatever I told you till now, if you didn't understand majority of it, it's fine. Not that you're in elect, not that your grade and CG is going to get affected by this. So yeah, so basically at the end, when you're making robots, you'll be dealing with something called a development board. So this is ESP32S Node MCU version 1.1. So why a big name? So ESP32S is the microcontroller. They also use Vroom only. So they have ESP32 chip in it. Apart from that, Node MCU is a company. They make open source development boards just like ESP32, but I don't know why we actually use them. Maybe their product is maybe cheaper in Chennai zone. I'm not sure about that, but actually, like an original ESP32 and a dev kit made by these people should be the same price. Yeah, I guess in Chennai, it's just that these boards are a bit cheaper than original Esperif development boards. That's why maybe like entire C5 has them. I'm not sure about that. But basically, this is one of the boards. Okay, so now, okay, till now, everything was a bit GK. Now we'll be learning things which are a bit more important towards programming, I guess. So, yeah. Uh, oh, I should probably share the link in the group. Okay, please open this on your laptop or okay, I guess regardless, I'll be showing it on my screen, but okay. So basically, what I shared just now is like an introductory guide to ESP32. So basically, it has all the important details. Okay, so what? Bro. Yeah, okay. The last 10 minutes which I yapped was the introduction, I guess. Okay, never mind. It was not the introduction, not completely. Yeah, okay. So, first of all, they gave some specifications. Right now, I don't think so. You know anything to compare with, so it's fine if you skip this. So reset and boot buttons. So, should I show it again on the camera? Oh, okay, that's better. Uh, okay, for now, I guess. Everything else. Okay, So this is your ESP32, and basically on this microcontroller, you have two buttons which are towards the pen. Okay, this is a metal pen. I shouldn't be touching. Yeah. So, oh, also, just telling this, never place your electronics on a metal table or handle them with metal stuff, because like even recently your seniors, like my co-coordinators and like co-project members, not co-project members, but like project members in the club, they have burned some microcontrollers because they put it on a metal table. I don't know why robotics club has a metal table, but yeah, just don't place them directly on a metal table or handle them with metal objects. Yeah, that's it. So basically, this is your micro USB jack, and uh, to okay, right, left. Okay, leave that. So basically, on one side you have a boot button. Whenever you are loading a fresh code, you have to press that button, and then you have a reset button, which will like basically restart your board. Yeah. Okay. Yeah, that's it. We have two buttons. One is for like loading code, other one is for resetting it. Now, the thing is, Arduino is like very limited or like not that great, because you have analog pins on one side, you have PWM on very less pins, and you have analog read on very less pins. I guess I'm repeating stuff now, but yeah, basically the thing is Arduino pins, they are very rigid. You can't like play around with them. But the thing is, when it comes to ESP32, each pin has like 4 or 5 functions on them. So basically, depending on the way you write your code, you can utilize the same pin in several ways. So I will be explaining it shortly. Uh, okay, I guess after this, oh, okay. These were like different ESP32s I was talking about. They're like bunch of series. Each one, like at this point, it's a bit stupid to compare, but basically when they get released or like how much RAM they have, they add a new letter and a new number. End of the day, what matters is like it's ESP32, I guess. But yeah, yeah, rest all is like lower, I guess. It's not that useful right now. Yeah. So basically, you can use Arduino IDE to program. One good thing about ESP32, it's completely compatible with Arduino IDE. So you have the biggest creator communities libraries on your fingertips. Why do I say so? Like, see, usually school children when they start off with Arduino Uno, and like there are like thousands of creators who make content related to Arduino Uno R3. So like there are a ton of libraries on Arduino. Uh, Both Arduino and ESP are open source, but I guess people thought ESP is from China, so like why bother making libraries on it? There are libraries, but yeah, Arduino has way more libraries. I don't know why. So yeah, so basically you have same ID. Now I guess my output part might look a bit weird, because like for one of my courses, like I had to change my USB library. So basically, like everything might be a bit different. I'm not sure. So yeah, uh, this is instruction manual on like how to start programming, because there are some small settings that you have to change when you're working with ESP32. All of that. Okay, see, I'll also mention one more thing. We have an entire 1 month dedicated workshop phase for electronics. So like, I know it's a bit weird to learn electronics without having them. So yeah, that's why we have a workshop phase for sure afterwards. So yeah, right now I didn't want to write codes, so I already wrote them. Uh, in the sense, I didn't want to write them like during the session. So yeah, so I'll just compile it. And the thing is, when it is done with compilation and it starts to load, I will like time it so that I pressed the boot button. So also, I guess if my video is visible, like you can see, I have to press the boot button while loading the code. So yeah, once it starts loading, I'll just like stop pressing it. I hope my even like my video is on your screen, or is it that only my like share screen is on your screen? Okay, there was one thumbs up, so I'll assume okay. Yeah, okay. I assume it was visible. So yeah, okay. Okay, I guess you might be a bit confused what you're seeing on your screen right now. So I took a very intelligent decision while coming to my home. I brought everything except LEDs. Like I even brought my workshop PCB from my SEM1 to my home from Institute, but I forgot to bring LEDs. So that's why I had to reuse this workshop board. Uh, there is Okay, see, don't overthink much. Basically, I had this board and these two pins. Uh, this pin was connected to cathode of a LED, and this pin was connected to a resistor which was going into the anode. So basically, I was able to repurpose this, and I'm actually a bit happy that I did do it in time, so like I can show it to you guys. So right now, I'm using LED pin 2, and okay, I hope everyone can understand at least this code completely. Please go through this once, and once if you understand, please raise your hands. What? You read the entire code in 5 seconds? Crazy, bro. I really hope you guys are reading the code and not like blindly raising your hands. Okay, put a message. All of you who raised your hands, put a message what this is. I don't care if the answer is repeating, just put a message. Code. Hey, bro, what does the code do? Yeah, okay, yeah, please, thanks. Blinking LED, long, blink. Yeah, yes, perfect. So it's a blinking LED code. Now, why did I choose pin 2? It just so happens that pin 2 of ESP32 is connected to its internal LED. This blue LED glowing is like internally connected to pin 2. And also, I have an external pin called pin 2. That is what they were explaining in that page, I guess. Oh, okay. Okay, sure. Let's move to next page. This is GPIO pins. Now, GPIO pins are general purpose input output, but at this point, it just so happens that ESP has groups of pins which are like used for digital inputs, digital outputs, and analog outputs. So we'll go through them one by one. You, Jason, sorry, bro. I didn't let you in earlier. I have recorded the session, so please go through the first 30 minutes. Yeah, sorry about that. So, yeah, GPIO pins. So, basically, bunch of pins which you can program. So, right now, you can just see that in your ESP32, all the pins have GPIO. Sorry, all the pins have PWM. My bad. The tilde is like, yeah, you can do PWM on that pin. So as you can see, and there are like 34 pins, and apart from like 6 or so, like 28 or so pins have PWM. That's like way better than Arduino. Arduino is dumb bad. Oh, okay. Newer Arduinos are actually good, I guess. I am not sure. But yeah, till R4, like the pin scene was a bit cooked. So yeah, starting off with digital output. So basically, same like Arduino, you declare your pin mode and then you do digital write. So those of you who know what digital write is, kindly raise your hands. 17 people. 22 people.
Can you
20.
repeat? I didn't hear.
Those of you who know what digital right is, please raise your hands. That's what I told just now.
All right.
Why do we need PWM pins in ESP32? Don't you have
What?
a DAC?
I didn't get
In
you. What?
in ESP32, like there are a lot of PWM pins, right?
Yeah.
Don't you already have like a DAC in ESP32? Why do you need PWM pins?
Okay, see, the thing is, DAC, DACs are very costly to have, and there are only two DACs on ESP32. So the thing is, like, the proper DACs you have two, but you also have 28 pins which can function like a pseudo DAC. That just means that you can control a lot of devices. Like, see, now, for example, when you have a spider bot, you'll have 3 into 4, you'll have 12 servos. That means that you need 12 PWM outputs. And that is for a 4-leg spider bot. And I think so. We also, I think so, like our seniors, E22 people, they worked on a 8-leg spider bot. So that's a 24 servo output. So to be honest, like Arduino cannot control those types of robots. Did you get my point?
Yeah.
Yeah, DACs are costlier, and we have DAC alternative, which is high in number. So yeah, basically that's it. So yeah, let everyone raise your hands. So Naren, Roy, Judah, Shreyasi, Kritisha, Prego, Divyanshu, you people don't know what digital right is, and Nikhil, and I can't see one person's name. Surya. Okay, still Roy and Divyanshu. Or Nikhil Guha. Yo, yo, Nikhil, are you even listening to the class, bro? If you don't know, don't raise your hand. If you know, raise your hand. If you know what digital right is, raise your hand. Hey, Guha. Hey, Nikhil.
Yes, yes.
Hey, were you sleeping? No attendance for you, bro.
Hey, no, I'm there.
What was I talking about?
No, I mean, right now I went to bathroom and I came back.
Okay, bro. Hey, Sanmitra, what about you? You also aren't raising your hands.
No,
Or
I
like,
was raised. I thought like it's done now.
no, 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 no. I'm looking around. Hey, Guha, meet me afterwards, bro. I'll book your ass when you come back for sem 2. Or more like you're getting bonus tasks. A lot of bonus tasks. Hey, light. You came back in time. Fine. So yeah. So that's what digital right is. So okay, you can either have input set. Sorry, you can either write it to high or write it to low. So right now I had this code which was loaded into my ESP32. I declared my LED pin or pin 2 as output, and then I set it to high, gave a delay of 1 second, and then set it to low. And this is how it looks like right now. Hey, Nikhil, what is this board? Explain me.
ESP32,
No, the other one, the yellow color one.
the yellow color one, that looks like a PCB board.
Okay, sure. Where did I get it from?
You got it from the workshop.
Okay, cool. Okay, safe. Yeah. I loaded this blinking LED code. So as you can see, like that one particular LED which is connected to pin 2, it is glowing and like unglowing. Okay. Basically, I'm digital writing high, having 1 second delay, and digital writing it to low. I am pretty sure, like I made all of you make this on Arduino Uno R3. I hope all of you submitted assignment. Which assignment? Yeah, no. I'm glowing. Yes, sir. Yeah, I hope all of you submitted assignment. So can you raise your hands once, like? Those of you who submitted assignment, please raise your hands. Okay, 30 plus, that's decent. Okay, 31, 33. Okay, cool. Okay, cool. That's fine. So basically, the first question was implement the same code on Arduino Uno R3. Basically, write all of this, and at this point, you can just load the same code because till now we didn't find a single change between ESP32 and Arduino. Like coding wise, like usually there are some differences. We will come across soon. Also, like see, there is a bit more content. And okay, point one, if you're doing digital write high, please don't connect the pin directly to ground. You will fry your laptop and your board. And if you're doing digital write ground, don't connect that pin to +5 volts. You'll fry your laptop. You'll fry your USB port and you'll fry the board. So yeah, please don't do that. These are some like basic instructions.
Can you come again?
If you're digital writing a pin too high, please don't short it to ground. And if you're digital writing a pin too low, please don't short it to +5 volts. Because basically, delta V by R equals to I, delta V will become 3.3, R will become 0, and your I current will become infinity. So yeah, basically you'll damage all your components. So these are some generic precautions that even like the electronics workshop people, okay, those guys won't tell you, bro. I guess these things I have to repeat during workshop phase. But yeah, basically, these are some generic precautions. I recommend that you guys read all of this. If not, I will be yelling these during the workshop session again. Yeah. So basically, don't short your wires. Be careful with them. Next, we have ADC. What is ADC? Analog to digital converter. Now, on your Arduino Uno R3, you have only 6 pins, A0 to A5. But as you can clearly see here, there are like 9, 12, 15, 16. How many are there? Yeah, there are 16 onboard ADC channels. That's like 3 times more than Arduino. So that means that you can read 3 times more sensors than Arduino. So I have a potentiometer lying around, but I'm too lazy to make this circuit now because I don't know, bro. I guess I'll take this as assignment. I'll mention this afterwards. On Wokwi, you have to make a potentiometer, read its Weikel value and print it. The code should be 3 lines. It's just to familiarize you with Wokwi, but totally not me being lazy. Or else I guess be happy. I'm not giving you a complicated assignment now. Oh, also, I guess the number of bits allotted for your ADC is 12 bits here. So 2 power 12, 4, 1024, 4096. Yeah. So this you can do analog read from 0 to 3.3 volts, and the value will be represented linearly where 4095. Yeah, 4095 will be corresponding to 3.3 volts and 0 should be corresponding to 0. What? Why does 0 start at 10? Oh, this is ADC tag. Okay. Regardless, this is. Oh, wait, did we reach? But. Okay, I'm a bit confused. Analog to digital analog device, the dark formula here. Yeah, okay, sure. I guess this V out is what we are measuring. I guess that's what it is right now. But yeah, basically your 0 volts will be mapped to 0, 3.3 volts will be mapped to 4095. So Basically, if you have a sensor, you can use it a bit more efficiently. Now, basically, when you have sensors, this is how they would look like. This is a bare metal sensor. In the sense, it doesn't have a module with it. Give me 1 minute. I'll try to get a module too. Okay, I didn't find my air sensor. So I found something else. So this is a gyroscope sensor. So right here you have a gyro, and this sensor is actually too small to handle directly. But usually, if you have a very like slightly large sensor, you'll have something which produces that value, and you can actually get it directly. Okay, wait, it's better if I. Yeah. So DHT line module. Yeah. Okay. This is what I wanted to show you, I guess. So you can either get a direct sensor, or you can have it on a module. And the thing is, usually the output is an analog value. And the thing is, when you have more bits allocated to reading the analog value, what happens is that you get more clarity, you'll get more control, and you can like get more precision out of that same uh, 55 rupee sensor. Like your 55 rupee sensor, it becomes 4 times more precise. Not accurate, but precise. I hope you know what the difference is, or I hope I remember the difference correctly. Yeah. So that's it for the ADC. I guess you have to write your ADC on your own. Next, PWM. This was the second question, if I remember correctly, breathing LED. And even here, majority of the code is same. These guys explained you duty cycles. And I wanted to explain duty cycles in the last session, but yeah. When you do PWM 0, it always stays 0. When you do it PWM to 25, 10% of the duty cycle in an Arduino goes up. And when you do PWM, you do analog write to 127. 50% of the duty cycle is on. So this is how the wave would look like. I hope you guys got the intuition behind PWM. So I guess one guy got it. 2 thumbs up. 3, 4, 5, 6, 7, 8. Okay. Okay, cool. So that's what PWM is. You have a fixed period, and in that, the amount of time you turn your or put your output to high and low, this is how the uh, difference would look like between 10%, 30%, and 70%. So basically, all these pins have PWM. And also, I guess I should have informed a bit earlier, but I guess this class will take 90 minutes. I hope it's interesting enough that you guys are willing to listen to 90 minutes of me yapping. If not, don't leave off. I guess stay in front of your laptop. I will like maybe ask questions in between. So basically, this is a basic C code. By this point, I asked you to go through W3S School's Basics of C. I asked you to do 2 C questions, although the questions weren't so good. And also I asked you one assignment which had 6-7 questions of C programming. So I hope that the code in front of you makes sense. You have a variable. This code is also a bit unnecessarily complicated for basic C. You have a for loop, you have a variable which will go from 0 to 255 and you will increment it. You will analog write that value to the same LED and you have a time delay. And then you have a for loop which goes from 255 to 0 and you decrement your variable. This is a bit more this is less complicated than the code which I showed you just now, and I'll load it onto my ESP. So like whenever I'm loading, like I'll just press this boot button. It's a bit painful to press the button, so usually I just time it enough that my sketch is compiled and like it starts loading. And once like the first two sections get filled, I just leave it. So yeah. Also, the thing is like during session one, I didn't set up my camera in the way I did now. So that's the reason I'm covering some topics again. So as you can see here, I have my breathing LED. So basically I analog write. Oh, is it? Okay, I guess I can go a bit higher for analog write. Okay, never mind. I guess it's a 8-bit channel for, is it 8-bit? It is 16-bit. That's interesting. Okay, so basically your analog write can go from 0 to 255. I don't know why it's 16-bit in that case, because it should be 255 6 whole square minus 1. Okay, I'll check it out later. But yeah, basically, this is how the code looks. I analog write my value 0 through 255 with a small delay. So as you can see, my both like the internal LED and this LED connected to pin 2 right now, it goes, it kind of breathes, or like it goes from 0 to 255, it inhales, and like 255 to 0, it exhales. It's up to you how you interpret the breathing part, but yeah. Sure, I guess that's it for breathing LED, but yeah. Now, essentially, you can have a ADC which would read the potentiometer Viper value and then it would print it out to LED. Oh, okay, I guess this is your second question for your assignment. On Wokwi, use a potentiometer and analog write to an LED. So yeah, that is how PWM would work here. And okay, next we have something called interrupt. Now, interrupt is not that useful for you right now. I'll go through it again during the workshop session or workshop phase. Interrupt is something, okay, see, right now when you looked at the code, let's take, okay, don't get overwhelmed by the code that is in front of you. It as of now, just think that this is a very big code, and the thing is, your code gets executed line by line. So what happens is when you have a very uh, extremely long code, something like running a ML model which controls your spider robot, you'll have code which would be like maybe 3,000 lines or so. Okay, 3,000 is a bit too much, maybe 600, 700, and you have a ML model running in the background. So the thing is, each iteration would maybe take 500 milliseconds or so. And the thing is, suppose you program your spider bot to walk on the edge of a skyscraper which has no railings. You have to actively check whether there is floor in front of you or not. So what interrupt is that? Interrupt is a value, or interrupt is something which can be raised regardless of its one tip. What? Okay. Yeah, okay, sure. Okay. Light, but yeah. So basically, when you have extremely large codes running, uh, should I? Hmm, do I have those things? Okay, never mind. So, hmm. Okay, see, the thing is, when you write your custom header files, the thing is, your code is going to go extremely large. Like, um, okay, take light for now, but I'm just saying that when you start including header files, which look like this, each header file will have 1 to 2K lines on your own. Your base code will be small, but the thing is, you will be having a ton of header files, and like you will be calling a lot of stuff. So the thing is, it will take a lot of time to run. So what happens is that you have these things called interrupts, and the thing is, whenever an interrupt is raised, your microcontroller, it will let go of everything else and it will first sort out this interrupt. So this is extremely powerful. So in the case which I told you, a spider bot is walking on a skyscraper which has no railings. Your robot shouldn't fall off. So what you'll do, you'll have some sensors which will be looking at the floor, and as soon as you realize that there's no floor ahead of you, you'll raise an interrupt, and your code will take action in such a way that you'll first like reroute your entire robot to go in a new direction, and once your interrupt is cleared, you'll go back to your old code. You'll again maybe start walking in a straight line. So see, there are I recommend that you skip this entire page as of now. It's a bit useless only. And next, you have a DAC, digital to analog, and basically, what is a true DAC? It will print an intermediate value between 0 to 3.3 volts when you give some value, rather than having a pulse width modulation. Like you're no longer doing this funny stuff. I should have made a DAC code actually. Okay, I guess I'll write a DAC code afterwards. To be honest, already it's getting a bit late. I will. Oh, okay, that's comfortable. Okay, and I'll also tell you one rule of thumb. Whenever you're doing CP, or whenever you're programming your development boards, you will be going through external resources. And the thing is, when you refer any external resource, please type your code while looking at their code. Like switch between tabs and type line by line. Right now, because I had less time, I just printed it. But usually, whenever possible, I just like look at external codes and uh, yeah, I type them line by line. Why? You should know how your code works, because when you start copy pasting like a 70, 80, maybe snake game code or something. Uh, okay. So yeah, this is a snake game code, and how long is it? Yeah, it is 200 lines. I typed this in a single setting. It took me around 1 hour or so. But yeah, so when you start making a bit complicated project and when you write it on your own, first issue, ChatGPT is not a programmer. It is a very what do you say, a bit advanced web scraper. When you ask for a code, it will go to a website like what you're looking at right now. It will scrape this, it will run it through its language model and it will make sure that it explains it a bit better. And then it will just throw that code at your face. Now, the thing is, this is a snake game. It is extremely common. And in between, I had some glitches which I wanted to sort out. And after spending around 30 minutes on ChatGPT, it finally told me where the glitch was. And like, see, this code itself, it is 200 lines. On internet, when you give your own codes or generate codes, when you try to change small things, ChatGPT doesn't have the ability to change it properly. And then there should be another game here. Oh yeah, okay, this thing. Now, this thing is last year's Shastra embedded programming challenge question 3 round 2. Yeah. So I guess I okay. I am part of that team. That's why I remember that it is also a PYQ. But I guess some of you might have heard of this thing. So the thing is, when you go to competitions like our own Shastra's competition, they'll give you a very, what do you say, bit weird of a question. So here I had to make a different game. This code also took me 1 hour, but the thing is, ChatGPT, at least model 2, couldn't figure out a single mistake in this code. Like, I asked it for 30 minutes, it was useless. So I had to ask my senior on like how to fix a particular bug, and he had to like manually tell me what mistake I was doing. Like, there was a small issue with like the order of taking decisions and order of printing my output. So the thing is that after the point of time, ChatGPT is useless. And because I typed my own code, my senior, he didn't bother to read through the code. It was just too long. So he told me like, this is the order. So I had to manually change it. So yeah, okay, I guess I was yapping for too long, but it was breathing a little. Yeah, end of the day, please don't copy paste codes like I did just now. Oh, wait. It will be connected to a different pin. That one is pin 25. That's pin 20. It's the 9th last pin. Okay, sure. Last pin from its side. Hmm. Okay, I guess. Hmm. Once I figured that out, I guess I'll. Hmm. Okay, one small issue, I guess. The pins are mapped a bit differently on my board and this particular board, which is made by ESP company. Like I told, I was using Node MCU. I guess I'll check out the pin map and okay, I'll send a video afterwards, which would be covering back. Okay. Okay, sure. After this, okay. See, now also there is this very good feature in ESP32 called touch sense. Basically, you connect any wire to your ESP32 and you touch that wire. Your ESP32 has the capability of telling that you touched it. Now, how does this work? There is like 2 paragraphs which tell you how it works. It's like capacitive touch, and like basically your body has charges, and when you touch that wire, it will see that, oh, there is some charge now. So it will have a capacitor and a voltmeter like structure across the capacitor. When you touch the wire, the capacitor gets charged, and it's like, oh, my capacitor got charged somehow. That's what happens behind the scenes. So essentially, you have something called touch read, and you can maybe okay, you can just connect the aluminum foil to your pin. Which one is this? Pin G4. You can touch that aluminum foil and you can make a blinking LED code. I guess it would be fun to do this during workshop session. We'll get we have a metal table somewhere, right? We'll connect the pin to metal table, and whenever one of you would touch the metal table, some LED would glow. So it would be something which we can make within 5 minutes. But Roy, you raised your hand. Do you have any doubt? Okay, I'll take it that you don't have doubt. Okay. And one more very good thing about ESP32, you have power saving modes. Now, I told you that ESP32 has a ton of modules, Wi-Fi module, Bluetooth module. So it just also happens that the manufacturer has put like 5 modes on it. And depending on what power mode you select, you can turn off the heaviest modules, the second heaviest modules, and then the peripherals also. So yeah, you can basically optimize your power consumption. Why? Okay, see, sometimes you don't connect your projects to direct power sources. So usually I connect my projects to my power bank once I'm done coding. So practically, as you can see here, in the most active configuration, it would take 240 milliamperes, and in a decent working configuration, it would take 0.8 amperes. So basically, if my project could run uh, maybe 10 hours on the most powerful setting, I also have a setting where it would run for 10 days. 10 days, is that so? 1,000 hours? Oh, 100 hours. Okay, 4 days, my bad. Yeah. So basically, you have several power saving modes too. So as you can see already, Arduino looks very bad in front of a basic ESP32. And this thing is for the same price. That's what I was trying to say. And also in the beginning, I mentioned there was like a Hall effect sensor. So hmm. Yeah, basically this one thing which is sitting inside your Vroom module, it is a Hall effect sensor, or I think so. It's a Hall effect sensor. It should be. I don't think so. There's a Hall effect sensor somewhere hidden. But yeah, basically your Vroom module also has a Hall effect sensor. So basically you can put a magnet to it, and it will tell you whether the North Pole is facing and with what intensity. I guess in PH 1010 you would learn about magnetic field, or is it PH 1020? What is that? Crystal oscillator thing. Where, bro? Are you talking about Hall effect sensor? Oh, crystal oscillator is a clock. So it just so happens that, okay, see, you learned about damned SHMs in your 12th, right? So basically, we have quads lying around in soil. And it just so happens that when you put a voltage current across quads, it vibrates at 16 megahertz or something. So basically, everyone uses crystal oscillators as clocks. I I didn't study this in detail actually. I guess my prof did teach it in a course. I should have paid a bit more attention. But yeah, basically our crystal oscillators are standardized natural clocks. So yeah, that's it for Hall effect sensors. I'm also skipping timer interrupts. Timer interrupts, you set a timer and basically that timer will raise an interrupt. So you have timed interrupts. If you want, I would recommend you read this thing once afterwards. Okay, now this thing. Okay, I guess I'll wrap up a bit quickly now. Now, okay, see your ESP32. The main edge against Arduino is it has Wi-Fi and Bluetooth. Wi-Fi, it can. Okay, entire slide is useless thing. Okay, even this text, we can skip it as of now. Basically, you have two modes. Oh, you have three modes actually. You have a station mode, you have an access point mode, and you have a hybrid mode. Now, what is the access point? Your Mandakini routers, which you have in your room, or Swarna routers, those things are access points. Basically, your local network and your laptop, mobile, or personal computer gets connected to that access point as a station. So you have mode one, where you can connect your, what do you say, ESP32 to that modem, and on your local network, you can head over to, yeah, you can head over to a specified port. You'll get that port from code, and from there you can control your ESP32. You can do anything. Right now, I had a very basic code. I will run this code at the end of the class, and basically what happens is that over your Wi-Fi, you can turn the internal LED on or off. Now, what are the implications? You can make a Wi-Fi remote control car, which would run on ESP32, two motors. And okay, we have two-wheel drive kits. If Anubhav, Shaijesh, Ashwin, uh, Ajay, or like there are many DCs who took part in Robo Race, and in Robo Race, what we had was that we had two-wheel drive kits, and these kits can, in place of using a Uno, you can use a ESP32 on your kit, and using your phone, you can use it like a RC control car. Uh, I guess afterwards, those of you who worked on projects, maybe you can share your videos in DC group if the runner-ups or winners are here.
All right.
Yeah, okay, cool. So basically, you can convert that car into remote control. So that is implication of station mode. And then you have access point mode. You can run a modem from your ESP32. Now, for today's class, I actually wanted to do something. I wanted to host a website which would look like workflow on my ESP32, and also make my ESP32's Wi-Fi name to IIT. What's the Wi-Fi name which we have? How can I forget? The Wi-Fi signal which we get in blocks, MSB or ESB. What is that called?
IITM Wi-Fi.
IIT Wi-Fi.
Yeah, that thing. So I was trying to do this, but the thing is like, uh, ChatGPT told it's illegal, so it can't help me. I was trying something, but it didn't work. But potentially, if you are very good at this, you can host a website which looks like workflow or net access, and you can change your Wi-Fi's name to IITM Wi-Fi, and you can also, okay, it's a bit far-fetched. If once I learn it, I'll teach it to you guys. But yeah, basically you can do this, and you can go to places like maybe Usha Cafe, where there shouldn't be Wi-Fi, and you can ask your dumb friends to maybe connect to IITM Wi-Fi, or like show their CGPA. They have to connect to IITM Wi-Fi, and they see that, oh, there is IITM Wi-Fi somehow in Usha Cafe, and they'll log into it. They'll go to net access or maybe workflow, and you can get their LDAP credentials. Now, this is, see, ideally, if we were in maybe programming club or maybe SciSec club, we would have done way more sophisticated things. But this is also possible. I'm telling that electronics or like robotics people can also get credentials. It is not impossible for us, but yeah, I'm just telling. If one of you figures it out, very nice. I remember two or three of you guys being very capable in electronics. See, one issue is that SciSec people, they can get my credentials right now, and they can drop all my courses in maybe like 3 minutes. This thing, it will scrape my credentials in like 30 minutes or so, and you have to push your friend to do it. I'm just telling that this is also possible, but it's not that sophisticated or easy, or else SciSec people would be making this. Yeah. And next thing, Bluetooth capability. Now, what are implications of this? You can connect two speakers to your ESP32 and you can play your songs for, what do you say, maybe 500 rupees setup. Apart from that, okay, I'm a bit, I should have started with Bluetooth controlled spider robot. Yeah, you can control your spider robot using Bluetooth too. Okay, very good. So basically, you might get a doubt why have Wi-Fi and Bluetooth both. I'm not exactly sure, but I'm pretty sure that Bluetooth and Wi-Fi have a different bandwidth. So in case uh, you want to maybe communicate during an exam which has a Wi-Fi jammer, you can use Bluetooth. Or maybe if you want to use a Bluetooth device in a field where there is a Bluetooth jammer, you can use Wi-Fi. Like basically you have two signals or bandwidths, and usually a jammer which gets placed, they usually don't place it in both bandwidths. You either have a Wi-Fi jammer or a Bluetooth jammer. So just saying, having two different bandwidths, you can potentially, oh, ah, well, that is on you guys. Who told you to show your ID cards on phones? That is very stupid. Well, that is on you guys, bro. You guys have skill issue. I don't know why some of you guys showed your ID cards on phone. That is totally on you guys. We never had a blocker. And I don't think so. My seniors also had a blocker. How do you know, bro? Bro, I talked to the profs and like secretaries and like old people in our institute, bro. We never had a blocker. They were testing in ESB. Wow. Okay, very interesting. Actually, one of my profs did warn our entire batch that he would put a signal jammer, but he gave up on that idea because like he didn't have reasons to do that. But thanks to you, your batch, I guess all of us will have jammers. Okay, okay, I'll stop shitting on you guys. Yeah. So next thing, we have something called ESP32 cam. What is ESP32 cam? It's basically ESP32 on a smaller PCB with a camera. And what are its uses? YOLO models. I guess Aryan left in, um, I guess the timing was bad, but basically, what are YOLO models? They are machine learning models which can look at your camera and basically draw boxes. And okay, see, drawing boxes might seem stupid, but like higher implications are that you can have face recognition, you can have object recognition, or you can have intruder recognition, motion recognition, several forms of recognitions using very lightweight ML models. Now, there is this website called Edge Impulse. Now, so okay, see, I also discovered this recently. I was trying to make a project, and then I got to know that on ESP32s you can deploy very lightweight ML models, which are uh, made by or trained on this website to be a bit more accurate. So today I tried to make a voice recognition ML model which could run on my ESP32, but unfortunately I didn't have. I neither had the equipment nor I don't know, like nor I can navigate through this website completely yet. I don't know how ML works completely, so I couldn't do much. But those of you who are good with ML, I would highly recommend you check out Edge Impulse. And Edge Impulse need not only be deployed on ESP32s, you can deploy it on your laptop too. So you can potentially train ML model which can recognize your speech, and you can maybe open camera or open Chrome or maybe close YouTube and open a PDF which is a textbook. I guess it's useless now, you're too old. But yeah, when you are escaping from someone who wants you to study, you can have ML models which can maybe detect a door opening, and you can close YouTube or Prime Video, and you can instantly switch to a textbook. It is possible. It should be possible. I think so. I didn't try it out yet, but yeah. So basically, lightweight ML models which can even run on ESP32 development board, which is for 350 rupees. Oh, okay. Not thank you. Not thank you. I guess I forgot to add a Wokwi slide. Don't leave. If you leave, no attendance for you, bro. Oh, okay. So what is Wokwi? Wokwi is one more Tinkercad. You can head over to Google. You can type Wokwi. There will be this link. You can head over to Wokwi. You can register yourself at this part, and you can make ton of models. Now, I personally hate Wokwi. I extremely hate it. Why? Their UI is a bit chopped. You have to sometimes work with their JSON files when you have to change components. So, for example, suppose I want to make this red LED to green. I have to search for the component, which is my LED type Wokwi LED. I have to head over here. I have to go to color, and here in this JSON file, I will type green. And now my LED is green. Now, see, it is faster but more painful. I'd rather like manually change it, I guess. Oh yeah, there is a manual change thing, but I hate Wokwi because of this one reason. They have overcomplicated JSON files. Right now, like see, after staying in the institute for like 3 semesters and like finally learning about JSON files and using JSON files and websites and all, or like my assignments, now it doesn't seem complicated. But back when I joined the institute, I hated this website because I didn't know what JSON was. So yeah, I guess that's. So basically, you can head over to head over here. You can you should be able to make a new project somewhere here. Templates, yes, yeah. Yeah, okay, sure. You can head over there. You can make your own projects here. Majority of the stuff is similar to Tinkercad, but when you want to fine tune your stuff, uh, it becomes a bit irritating because you have to play around with this JSON file which has like extremely long values and all. So that is for Wokwi. I guess I did. Okay, sure. So yeah, I had this Wi-Fi tester. Give me like 5 minutes. I should be done with this. So yeah. So see, in afterwards we do have Wi-Fi session. So I'll just introduce you to Wi-Fi. So basically, you can have local networks. So for example, right now my laptop should be hosting. Yeah, my laptop is hosting a hotspot. Hotspot name is 67, and you can see the credentials here. And I have a decently small code. This is just blinking LED afterwards. This is actually useless right now. So basically, you have your Wi-Fi password. You set the setting to station. Then you connect it to your Wi-Fi, and yeah, you just blink your LED. Uh, hmm. Okay, any doubts? I guess this will take some time. Do you have any doubts? Was I clear? Also, please give me suggestions because I have never taught to a large group of people who are completely inactive. Like, I have teaching experience. Like, I was an Avanti mentor, but usually the situation there was a bit different. Like, because it was one person, like my mentee used to continuously reply, and it was a bit oriented to a single person. If any of you feel like you have recommendations or you want any changes in my teaching style, please mention it instead of 1.5 hours. Yeah, Roy, I get your point. I guess today I yapped a lot. Uh, I guess that's the point of me recording the entire session, and I will be taking permission from head and like uploading it to YouTube. Uh, okay, sure. Yeah, see, Roy, See, the thing is, learning is always a bit painful because it's a bit complicated stuff you're stepping into now. It's no longer just Arduino. You have a bit more complicated board. So there will be a lot of more features. And see, we are teaching you so that afterwards your capabilities would be better when we approach project phase. Like last year, my mini project was making a maze solver robot, and it's not. It's 3 months is too much time for just a maze solver robot. Yeah, okay, sir. So I'll just reset my. The code is loaded, and when I reset my what do you say, ESP32, you can see that initially it will say connecting to Wi-Fi, then it would say connected to Wi-Fi, and it would put my put the port which it was connected to, the local IP address. And actually, after this, I programmed it in such a way that it would just blink the internal LED. As you can see, once the code is done running, it's just blinking the LED. Now, this was just introduction to Wi-Fi. There is a very much better capability of this running web servers, which I wanted to show you. Yeah. What this code does, it is a Wi-Fi controlled LED. Okay, sure. It's going to take 4 or 5 minutes to compile. Any other okay doubts? That was feedback. Do you have any doubts? My attention is it's translucent. My attention span is over. Okay, wait for 2 minutes. I'll just show you how this Wi-Fi server works, and I'll let you go. Yeah, I'm sorry, bro. That's on me. But good job. Hey. No, I just put my finger over it, but the moment the compilation came to end and it just started to boot, I pressed it for like 5 seconds. Like I was just waiting because I didn't want to miss the point. See, compilation takes for 20-30 seconds. And if you miss that 5 second window, it will take you 30 more seconds. And at this point, I'll just punch my laptop and throw this thing into the dustbin if it takes 30 more seconds. See, the thing is, if you become a comp team member or a coordinator or a project member, there will be some times when it's 3 a.m. Tomorrow 9 a.m. some outside guy will be coming to give you money based on how good your project is, and your team lead is like, bro, this module, please get it running before 9 a.m. So you pull an all-nighter. It's 3 a.m. You're crying. You want to get some sleep, and like basically you don't want to delay stuff, so you'll pick up some habits to speed up your things. I guess I started ranting again. My bad. I was just trying to share my experience. It happened, but it happens. Uh, okay, see, I loaded a. How will I upload this video on YouTube? I hope the heads don't watch this video. Yeah, okay. So basically, I uploaded a code where. Wait, I'll just close the useless code. Yeah, I uploaded a very big code, and it's going to connect to my hotspot, and then it will entirety of this part is just a HTML code. It's just fancy HTML code. It's basically only 38 lines of code and HTML page, and this is what the HTML page is. And basically, I can turn it on, turn my LED on or off. I guess if you can watch my video right now, you should be able to see that it's turning on or off. If not, yeah, okay, sure. Perfect. So as you can see, I turn it off and it turns off. I turn it on and it turns on. Okay. I right now my ESP32 is connected to my laptop via a wire. That is a fair point, but usually I can just connect it to my what do you say, power bank, and I can communicate to my ESP32 over any device which I have on the same LAN. So yeah, that's it with the session. Attendance. Wait. Sorry, sir. 2 more minutes. Okay. Please put a message saying that you're present if you're still here. Adya, Abhirat, Ajay, Ashwin. Okay. You four can leave. Bhavishya, Tanmay, Divyanshu. Okay, you guys can leave. Next, Gautam, Jason, Chetan, Kritisha. Yep, you can leave. Uh, mm, Naren, Manasvi, Rafi, Nikhil. You guys can leave. Nisha, Vaidish, Prego, Pranav, Roy. Yeah, you guys can leave. Okay, Pranav, you can also leave. Both Pranavs. Sanjana, Sanmitra, Sarveshwar T, Sarveshwar S. Yeah, you guys can leave too. Shreyasi, Surya, Tanay, Tejas. Yep, you can leave too. Toshita, Vakhin, Vedant. Vigneshwar, Vishwa. Yeah, you guys can leave too. If you want to talk about anything, you can stay back. I'll crop that video before uploading it to YouTube. But yeah, if you have any doubts, you can leave. Okay, if you have any doubts, you can stay back.